Welcome to this video lecture, and now I will discuss the power flow calculation using Newton Raphson method. And this time we will solve one sample problem which is a 3-bus system. So we have a 3-bus system with bus 1, bus 2, and bus 3. This is connected with a transmission line I will assign bus 1 as slack bus. Bus 2 is a generator bus, and bus 3 as a load bus. So we have a generator and a generator in bus 2 and a load in bus 3. So this transmission line from bus 1 to bus 2 has an admittance of negative J10. From bus 1 to bus 3, we have negative J15. And from bus 2 to bus 3, we have negative J5. So the other parameters that are given will be set up in a table so that it is more easy to see the details of all the given variables. So this is a bus number. This is a type of bus. This is state variables. This voltage and angle. This is power injections. This is P and this is Q. Bus 1 is a slack bus. Bus 2 is a generator bus. Bus 3 is a load bus. So we have a given voltage of 1 per unit and 0 degrees for slack bus. And we have a given voltage of 0.99 per unit and a P of 0.85. For load bus, we have negative 1.2 for P and negative 0.7 for Q. So we have unknown state variables for bus 2, which is delta 2. For bus 3, we have delta 3 and B3. So in this example, we have unknown state variables. We have delta 2, delta 3, and B3. In my previous video lectures about Gauss-Seidel power flow calculation. I have said that for generator bus, we need to use reactive power equation and voltage equations. And for load bus, we only need voltage equation. But in this Newton Raphson power flow calculation, it is different. We need to remember that when the unknown state variable is angle, we need real power equations P, and when the unknown is voltage, we need reactive power equations. So in this sample problem, we need P2, P3, and Q3. So before we write the equations for P2, P3, and Q3, we will set up first the admittance matrix. So in this 3-bus system, we need a 3x3 admittance matrix. For Y12, we have negative J10. It is J10. For 113, we have negative J15. For Y11 is the sum of these two, which is negative J25. For Y21, we have also J10. For Y23, we have J5. And Y22 is negative J15. For Y31, we have also J15. For Y32, J5. And for Y33, we have negative J20. We will first discuss the details of the problem, like what are the given parameters, the variables to solve, and what are the required equations. Then afterwards, we will go to Octave MATLAB applications to write the script or write a programs that will result to our needed solutions. So now we will write the equations for P2, P3, and Q3. But before that, I will write the general equations for real power and reactive power. So for PK, for QK, so we will write the equations for P2. Cosine theta 21 plus delta 1 minus delta 2 plus y22 b2 b2 cosine theta 2 plus delta 2 minus delta 2 plus y23 b3 b2 cosine theta 23 plus delta 3 minus delta 2. So for P3, y31 b1 b3 cosine theta 31 plus delta 1 minus delta 3 plus y32 b2 b3 cosine theta 232 plus delta 2 minus delta 3 plus y33 b3 b3 cosine theta 33 plus delta 3 minus delta 3. So for Q3, negative y31 b1 b3 sine theta 31 plus delta 1 minus delta 3 minus y32 b2 b3 cosine theta 32 plus delta 2 minus delta 3 minus y33 b3 b3 sine theta 33 plus delta 3 minus delta 3. So we completed the required equations for P2, P3, and Q3. Now the next thing we will write is the Jacobian matrix. Our Jacobian matrix is also a 3 by 3 matrix. So J is equal to this 3 by 3 matrix. So this is J11, J11, J12, J13, J21, J22, J23, J31, J32, and J33. So for J11 element, we have a partial derivative of P2 in terms of delta 2. For J12, we have partial derivative of P2 in terms of delta 3. For J13, partial derivative of P2 in terms of B3. So this is P2, P3, and Q3. So this is delta 2, delta 3, and B3. So for J21, we have a partial derivative of P3 in terms of delta 2. For J22, partial derivative of P3 in terms of delta 3. For J23, partial derivative of P3 in terms of B3. For J31, partial derivative of Q3 in terms of delta 2. For J32, partial derivative of Q3 in terms of delta 3. And for J33, partial derivative of Q3 in terms of B3. So we will write the elements of each Jacobian matrix. So for J11, which is the partial derivative of P2 in terms of delta 2, which is equal to, so we need to look for the functions of P2. So this is the functions of P2. So we will get the partial derivative of P2 in terms of delta 2. So in the first term of this equation, we have delta 2. We have also delta 2 in second term and delta 2 in the third term. So for the first term, we have negative delta 2. And the derivative of cosine is negative sine. So negative sine times negative is positive. So for the first term, we have y21 b1 b2 sine delta 21 plus delta 1 minus delta 2. So for J11, we have y21 b1 b2 sine theta 21 plus delta 1 minus delta 2. So we look again for the functions P2. So in the second term, we have also delta 2, but this will be cancelled because delta 2 minus delta 2, this is cancelled. So for number 3 terms, we have also delta 2, which is negative, and negative sign to negative is positive. So we have positive y23 b3 b2 sine delta 23 plus delta 3 minus delta 2. So plus y23 b3 b2 sine theta 23 plus delta 3 minus delta 2. So for J12, which is partial derivative of P2 in terms of delta 3. So we look again for functions P2 in terms of delta 3. So we don't have delta 3 in the first and second term, but we have delta 3 in the third term. So the derivative of cosine is negative sine. So we have negative y23 b3 b2 sine theta 23 plus delta 3 minus delta 2. So for J12, Y23, B3, B2 sine theta 23 plus delta 3 minus delta 2. So for J13, this is partial derivative of P2 in terms of B3. So we look again for the function P2 in terms of B3. So we have now B3 in first term, we have now B3 in the second term, and we have B3 in the third term. So we have Y23 B2 cosine. So J13 is equal to Y23 B2 cosine theta 23 plus delta 3 minus delta 2. So for J21, this is partial derivative of P3 in terms of delta 2. So we look for the functions of P3 in terms of delta 2. So in P3, we have delta 2 in the second term, and we have no delta 2 in the first and second and third term. So the derivative of cosine is negative sine. So this will become negative Y32 B2 B3. So J21 is negative Y32 B2 B3 sine theta 31 plus delta 2 minus delta 3. So the next is J22. This is the partial derivative of P3 in terms of delta 3. So we look again for function P3 in terms of delta 3. So we have delta 3 in the first term. We have also delta 3 in the second term. And we have also delta 3 in the third term. But this will be cancelled. So in the first term, we have negative delta 3. And the derivative of cosine is negative sine. So it becomes positive. Positive Y31 B1 B3. Y31 B1 B3 sine theta 31 plus delta 1 minus delta 3. So for the second term, we have negative delta 3 and the derivative of cosine is negative sine. So we have also positive Y32 B2 B3 plus Y32 B2 B3 sine theta 32 plus delta 2 minus delta 3. So the next is J23, which is the partial derivative of P3 in terms of B3. So we look again for P3 in terms of B3. So we have B3 in the first term. We have also B3 in the second term, and we have 2 B3 in the third term, which is B3 square. So for first term, we have y31b1 cosine y31b1 cosine theta 31 plus delta 1 minus delta 3. So for the second term, y32b2 cosine plus y32b2 cosine theta 32 plus delta 2 minus delta 3. So for the third term, we have 2b3 which is equal to b3 square. So we write 2 in front of y33. So it becomes 2y33b3 plus 2y33b3 cosine theta 33. So for J31, this is a partial derivative of Q3 in terms of delta 2. It is equal to, we look for function Q3 in terms of delta 2. So in the first term, we have no delta 2. In the second term, we have delta 2. And we have no delta 2 in the third term. So the derivative of cosine is negative sign. And this is negative. So we have positive y32 b2 b3. y32 b2 b3 cosine theta 32 plus delta 2 minus delta 3. This is the partial derivative of Q3 in terms of delta 3. So we look again for Q3 and delta 3. So we have delta 3 in the first term. We have also delta 3 in the second term. And we have also delta 3 in the third term. But this will be cancelled. So in the first term, we have negative delta 3. But the derivative of sine is positive cosine. So negative is positive. So this is y31 b1 b3 cosine theta 31 plus delta 1 minus delta 3. So for the second term, we have delta 3 negative positive y32 b2 b3. So plus y31 b2 b3 cosine theta 32 plus delta 2 minus delta 3. So for the last elements, J33, which is the partial derivative of Q3 in terms of B3. So we look again for function Q3 in terms of B3. So we have B3 in the first term, we have also B3 in the second term, and we have also 2B3 in the third term. So for the first term, we have negative y31b1 sine negative y31 b1 sine theta 31 plus delta 1 minus delta 3. So for the second term, negative y32b2 negative y32b2 sine theta 32 plus delta 2 minus delta 3. For the last term, we have p3 square. So 2 will be right in front of y33. So this will become 2y33b3 sine. This is minus 2y33b3 sine theta 33. So we completed the Jacobian elements. We will go to Octave MATLAB applications to write all the necessary equations so that we will solve the solutions for this problem. Now we are here at Octave applications window to write all the needed equations we already discussed. Now we need to open a blank U script. I will write first the admittance elements. Y1 equal to now we will define the angle. Next is we will define the known state variables. Delta 1 is equal to 0. P1 is equal to 1. P2 is equal to 0.99. Next is we will define the power injections. P2 is equal to 0.85. P is equal to negative 1.2. Q3 is equal to negative 0.7. Next is we will define the initial values of unknown variables. T2 is equal to 0. T equal 0. T3 is equal to 0. Next is we will define the equations for real power P2. We will first define the matrix of X. Now we will define the partial derivatives of Jacobian elements. Now we will define the partial derivatives of Jacobian elements. I will just copy the printing code. I think we were completed the script writing. So we save this. Now we will run the simulations. So we have an output. We have a three iterations wherein it gave us B3 is equal to 0.9589 per unit. D2 is equal to 2.35 degrees and D3 is equal to negative 3.01 degrees. So that's all. Thank you very much.